After completing our understanding of surface areas of cube and cuboid, now it is time for us to apply our understanding in solving the problems of exercise 13.1 of NCERT. So let us apply our understanding and let us see how much we have understood and what we have understood is coming to our help or not. If we remember the understanding, then we will not have any problem solving any of the problem. The first question, a plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is opened at the top. Ignoring the thickness of the plastic, determine A, the area of the sheet required for making the box, B, the cost of sheet for it, if a sheet measuring 1 meter square cost rupees 20. While understanding the concept, we have understood that a cuboid takes a shape like this. Cuboid is like this. Here the dimensions are given. Length is this, L, which is 1.5 meter. Height is 65 centimeter. This breadth is 1.25 meter. If we are able to visualize this and see and understand this in our mind, then on a piece of paper this will look like this. This is 1.5 meter length, breadth is 1.25 meter, height is 65 centimeter. Okay. The first thing in any of the problems which we come across, it is important for us to see the units of all the things. We see that length and breadth are having unit of meter and height is having unit of centimeter. So it is important for us to convert this height into meter first. So converting this height into meter, from centimeter to meter, we need to divide centimeter by 100. Only then it will become meter. So this will become 0.65 meter. So now our dimensions will be L is 1.5 meter, B is 1.25 meter, H is 0.65 meter. This is the first thing which we need to do, because dimensions, if we do not convert, then this creates problem. We do calculations and later on we find that whatever we have did has got no meaning because we have taken the dimension wrong. So it is important for us to first convert the dimension into a single unit. Every dimension should have the same unit. Now, after this, it is also written in the second line that it is opened at the top. This top, this is top, this is bottom. Opened at top means a regular cuboid has 6 faces, one front, other rear, this pair, front rear pair, this side pair, up and down pair. This top pair, this top and down pair has got no top. Means now in this case, in this particular problem, we have got 5 faces. These, the pair of front and rear, the pair of these two side and the bottom one. So these front and rear and this side too, these are lateral surfaces, and we will add the area of the base and then we will get the area of this plastic box. For knowing the area of plastic box, what we need to do, because it is open at the top, so we need to calculate area of lateral surfaces, that is front and rear rectangles, this side two rectangles and the bottom one rectangle. So based on our understanding of this, we can very well say the area of this box will be equal to this base. This base has got length and breadth. Length and breadth. So the base area is LB and plus this lateral surface area. Lateral surface area is 2L into H, LH, LH, 2LH, BH, BH, 2BH, 2LH plus 2BH. This will be the required area of box. Now putting L is equal to 1.5 and B is equal to 1.25 plus, you see here 2H is common, so we take 2 into H 0.65 outside and put a bracket here, L plus B, so 1.5 plus 1.25. Upon calculating this, we will get the area as 5.45 meter square. 5.45. I am writing it clearly because may not be good visibility in video, so I am writing it in bold and bigger font. Upon calculating, we will get area as this. Now the second part is cost of the sheet for it. If a sheet measuring 1 meter square cost rupees 20. If a sheet measuring 1 meter square cost 20, then the required cost would be, if we know the cost of 1 meter square, we have got 5.45 meter square. So we need to multiply this 5.45 with the cost of 1 meter square, that is 20, and we get this as 109 rupees. So this is the first question. Now coming to the second question of exercise 13.1. The question is, the length, breadth and height of a room are 5 meter, 4 meter and 3 meter respectively. Find the cost of whitewashing the walls of the room and the ceiling at the rate of rupees 7.5 per meter square. In any such problem, we need to first visualize what is the question. This is the keyword, length. This length, breadth and height is given. This is given because the length, breadth and height of a room. Room is also a type of cuboid, because this room, if you are able to visualize, will give a look of cuboid. So this will be like this, and length, breadth and height is given. Upon drawing it on piece of paper, we get a picture like this. This is length, this is breadth and this is height, and this is given. This is the dimension of length, breadth and height of a room. Okay, then find the cost of whitewashing the walls of the room and the ceiling. This is the important thing for us to notice. And the ceiling. Here base is not there because whitewashing is not done on floor. So here it is written it is to be done, whitewashing is to be done on the 4 walls and the ceiling. So while considering or calculating the area, we will be calculating the area of 4 walls and ceiling only. So for getting that particular area, we will be interested in knowing the lateral surface area plus the top ceiling. Lateral surface area plus top. What is lateral surface area? These two rectangles in front and below. These two rectangles side by side, opposite to each other, and the top rectangle. So what will be the required area? The required area will be, what will be the top? Top is again L into B. Top is LB plus the lateral surface area. Lateral surface area 2H L plus B. So upon putting the values, this is length 5 into 4 plus 2 into 3 L plus B, 5 plus 4. So this is 20 plus 6 and 54. So this is will be 74 meter square. Okay. So if we are able to visualize this thing clearly, that what area we need to calculate, that is the important thing. So what area we need to calculate? The top LB and the 4 walls. 4 walls means lateral surface area. Lateral surface, 2 pair of BH and 2 pair of LH. 2 pair of LH and 2 pair of BH. So this is. Now what is the cost? 1 meter square cost 7.5. So the cost will be, we multiply this 74 with this 7.5 and we get how much? 555. This is the answer. So this is our second. Now come to the third question. The third question is, the floor of a rectangular hall has a perimeter 250 meter. If the cost of painting the 4 walls at the rate of rupees 10 per meter square is rupees 15,000, find the height of the hall. It is again a question of rectangular hall. Rectangular hall is a cuboid. Rectangular hall is a cuboid. Rectangular hall is a cuboid. It has got 6 faces. This cuboid. This figure I am again and again showing so that this comes in mind. Here, what the question said? The floor of a rectangular hall has a perimeter. The perimeter of floor is given. Perimeter of floor. Floor is again a rectangle. So what is the perimeter of a rectangle? 2L plus B. Because this is L, this is B. L plus B plus L plus B. So 2L plus B. And this is equal to 250 as per the question. It is given. As per question that perimeter of the floor is given. Now, then another thing which is given is the uh, rate at which these walls are getting rate of painting is given. Rate of painting is given as rupees 10 per square meter. And it is also given that with this rate, the cost which is coming for painting the four walls, the cost of painting the four walls, that comes as rupees 15,000. This 15,000 is cost which comes when we get it painted by a rate rupees 10 per meter square. So if we know this much cost comes with this rate of painting, then we can easily know the area. How? Area will be this cost divided by rate. Cost is 15,000 divided by rate is 10. So this rupees 1,000, this is area. So this is 1,500 meter square. So area of the four wall, we have calculated. Area of the four wall we have calculated. From the question, it was given that rate of painting was this, total cost that comes by getting it painted from this rate is this. So we can easily get cost divided by rate is equal to this area which the four wall constitute. Now these four walls, area of four wall is area of this four wall, 1, 2, 3, 4. This area of four wall is what? Lateral surface area. So this is LSA. And what is LSA? 2H L plus B. And this is equal to this 1,500 which we have calculated. And 2 into L plus B, that was given. 2 into L plus B was the perimeter of the floor which was given. So here we can always write 2 into L plus B is equal to 250. So 250 into H is equal to 1,500. So H is equal to 1,500 divided by 250, and this will come as 6 meter. If anybody has got any understanding problem in calculating area, then you can also assume that let the area be x. Then area multiplied by this rate should be equal to this, and x will come out what? 15,000 divided by 10. So this is same thing. I don't think anybody will have problem understanding why we have divided cost with rate to calculate the total area. You assume area to be x meter square, then for 1 meter square rupees 10 is to be paid. So for x meter square 10x would be equal to this. So x is equal to 15,000 divided by 10, and this is what I have written. So this is the third question. Now coming to the fourth question. The paint in a certain container is sufficient to paint an area equal to 9.375 meters square. How many bricks of dimensions 22.5 cm into 10 cm into 7.5 cm can be painted out of this container? So after reading the question, we know that the container was having some paint which was able to paint an area of 9.375 meters square. The question says a container has got some paint which was able to paint an area equal to 9.375 meter square. From this paint, bricks are to be painted. The dimension of brick is given. The dimension of brick is again a cuboid. Brick is again a cuboid. Brick is again a cuboid. And the dimension of bricks are given. L is equal to 22.5 cm. B is equal to 10 cm. H is equal to 7.5 cm. This is the dimension of bricks which are to be painted. So let us we have to calculate how many bricks can be painted out of the paint lying in that container. So for knowing this, we should first know the area of each brick. If we know the area of each brick, then the total area which that paint can paint we know, and if we know the area of one brick, then we can say, let us assume that paint is able to paint x number of a number of bricks, and then when we will multiply the number of bricks with the area of one brick, then we will get the total area of bricks, and that should be equal to the area which can be painted out of that paint, and if we will equate, we will get the value of the variable. Doing that, we are calculating total surface area of each brick, and this is 2 LB plus BH plus H, which we know, all of us know. And this area, how much is this area? Area of each brick, 937.5 centimeter square. If we put the values, L is equal to 22.5, B is equal to 10, B is equal to 10, H is equal to 7.5, H is equal to 7.5, L is equal to 22.5, multiply by 2, we get the area of each brick as this. And we know from question that paint is able to paint an area of 9.375 meter square. Now let us assume that n bricks are to be painted out of that paint which was lying in the container. So area of total surface area, TSA, of n bricks, this is n into 937.5 centimeter square. From question, it is given that paint is sufficient to paint an area of 9.375 meter square. The TSA of we have assumed that this paint, which is able to paint an area of this, from this paint we are able to get n bricks painted. So the area, total surface area of n bricks we know, but this is in centimeter square. So, and the total area which that paint can is able to paint is 9.375 meter square. So we need to make these two into same units, and then upon equating we will get the value of n, because if that paint is able to n bricks, the areas of these n bricks should be equal to the area which can be painted out of that paint. So this should be equal to n into 937.5 9.937.5. This is centimeter square, so we are making it meter square, so we divide by 10 to the power 4. So value of n will be 9.375 divided by 937.5 into 10 to the power 4. One, two. And this is 100 bricks. This will be the answer. Upon calculating, we will get the value of n as 100 bricks, and this is the answer. I would again like to say, we have calculated area of one brick. Then we have assumed that suppose n bricks are getting painted out of that paint. So we multiply the area of one brick by n, and then we get the total area of bricks, or all the bricks which can be painted out of that paint is n. So n multiplied by area of one brick gives the total area of bricks, and we equate it with the area which can be painted out of that paint, and we get the value of n as 100 bricks. That's all. Now coming to the fifth question of exercise 13.1. A cubical box has each edge 10 centimeter. Another cuboid box is 12.5 centimeter long, 10 centimeter wide and 8 centimeter high. First, which box has the greater lateral surface area and by how much? Second, which box has the smaller total surface area and by how much? What we are able to understand from this question, there is a cuboid and there is a cube. What the question says? There is a cuboid and there is a cube. There is cubical box and there is cuboidal box. In case of cubical box, we know that all the sides are equal and this is 10 centimeter given. In case of cuboidal box, this is given, the dimensions are given as 12.5 centimeter into 10 centimeter into 8 centimeter. This is L, this is B, this is H. So, both the dimensions of cuboid and cube is given. Now, we need to know first which one has got the greater lateral surface and by how much. So, LSA, we need to know which one is having greater LSA. In case of this cuboid, LSA is what? 2H L plus B. 2H L plus B. 2H L plus B. This front and rear, side 2. Front and rear, side 2. So in case of cuboid, this is the LSA. In case of cube, what is LSA? In case of cube, what is LSA? 4a square. 4 cubes, 4 squares. So area of 4 squares, 4a square. Here, what is this? 4 into 10 square. That is 400 centimeters square. What is here? 2 into 8 L plus B. 12.5 plus 10. 22.5. So this is 45 into 8. This will come as 360 centimeters. So we can easily say the LSA, the first part of the question, the LSA of cube is more and the LSA of cuboid is less. And what is the difference? 400 minus 360, 40 centimeters. So 40 centimeters square. So the cube has got greater LSA and it is greater than cuboidal LSA by 40 centimeters square. First part is over. Now what is the second part? Second part is total surface area, TSA. Second part is what? TSA. So now the second part. See the second part. For second part, total surface area. What is total surface area of cuboid? 2 LB plus 2H L plus B. This one LSA and plus top and bottom. LB, 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 2LB and this lateral surface. In case of cube, this is 6a square. Putting these values in this we have putting this in, we will get 2 into L, 12.5 into B, 10 plus 2 into 8 L plus B, 22.5. 12.5 plus 10, 22.5. And what is this? 6 into 10 square. So this is 25, 250 and plus 360. And this is 600 centimeters square. 0 centimeters. So we get TSA of cuboid as 610 centimeters square and TSA of cube as 600 centimeters square. So in case of TSA, total surface area, we find that the total surface area of cuboid is more than cube by 10 centimeters square. This is the fifth question.